So in this video series, the first chapter we have is Algebra Basics, and within that we have 4 sub-chapters such as real numbers and their properties, algebraic manipulation, equations, inequalities, and functions. And for the first few videos, we'll be looking over real numbers and their properties. So within real numbers and their properties, we have intervals, which is the topic we'll be covering today. So we look at what an interval is, the representation of intervals on a number line. We'll look at interval notation. We'll compare that with inequality notation. We'll look at different types of intervals. We'll look at infinite intervals and union of intervals and intersection of intervals. The only assumed knowledge we have for this course is knowing what number sets are. So you should know what real numbers are, what natural numbers are, what rational numbers are, etc. So let's look at what intervals are. An interval is a range of real numbers between 2 points. What do I mean by points? I mean that 2 numbers. So I just mean 2 different numbers. So if you look at an example, say we have 2 and 3. An interval would contain all the real numbers between 2 and 3. So this could include numbers like 2.1. Or it could include something like 2.01, or it could include the number e, which is approximately 2.71, because that is also a real number, even though it has an infinite number of decimal values after. It's still within the range, and this interval would contain that. It could have something like 2.568 going on forever. So it would contain every single real number between these 2 points. And depending on how the interval is defined, it may include the endpoints or it may exclude them. So how do we define an interval on a number line? Before we look into that, let's look at what a number line is. So we have a line which is a section of all the numbers. So we could have 0, 1, 2, 3, and 4, and it goes on and continues on both sides. And it also includes every single real number between these 2 natural or integer numbers. So if you want to define an interval, say that starts from 0 and goes up to 3, how do we differentiate if we're including 0, if we're including 3, or if we're excluding them? So there is a convention that is used in math to define if we're including the numbers or if we're excluding them. If we're including them, we start with the circle that's shaded in, and if we're excluding them, we start with the circle that's not shaded in. So if you want to look at an interval that starts from 0 and 0 is included and goes all the way till 2, and 2 is also included, we'll shade in the circles on both sides and we'll connect the 2 points, indicating that every single number between these 2 numbers is included. And we could have something where it's excluded. So I could have a number that starts at 0 and 0 is excluded, and it goes all the way up to 3, where 3 is also excluded. Now, what does it mean if 0 is excluded? What it means is that we get like infinitely close to 0, but we never really reach it. So numbers like 0.0001 are included, and 0.00001 is included, and 0.000001 is included, but 0 is not included. And similarly, for 3, we have that 2.9 is included, or 2.99 is included, or we could have 2.99999, that's included, but 3 is not included. So we get crazily close to 0 or 3, but we never really reach 0 or 3. And just because an interval starts with a value that's including it or excluding it doesn't mean it has to end in the same way. So we could have an interval where we have 2, where 2 is not included, and it goes up till 3, but 3 is included. This is completely valid. or we could have an interval where we have a 1, where 1 is included, and we could go all the way up to 4, where 4 is not included. And if you're trying to represent intervals on a number line, this is basically how you do it. You draw a circle indicating the starting and the ending points, and you shade them in depending on whether those numbers are included or not, and you connect the two numbers together with a straight line. And now I would like you guys to attempt these questions one by one and try them on your own. Pause the video, and then after you guys have attempted them, I will show you the solutions and you guys can check if you got it correct or not. Okay, so first question says numbers that are less than 3 and they're not including the number 3. So from what we learned previously, we know that we're going to have to use a circle that's not shaded in for not including number 3. And then we can draw a number line, and we draw the arrows on both sides to show that it's continuing on both sides. And we can draw the number 3 over here and a circle that's not shaded in. Now it's asking us for numbers that are less than 3. Now if we know the number line, we know that numbers on this side are less than 3, because we would have 2, we would have 1, we would have 0, and so on. So we know that we're going to have to draw an arrow that's going in this direction. Now we do not have to connect this arrow to anything else because we're not given a range. We're just told that it's less than 3. We're not told that it's less than 3 and more than -1, for example. So we could just have an arrow pointing in the general direction towards the left-hand side, and that is enough to indicate that we're looking at all the numbers less than 3 and we're not reaching a specific number that's less than 3. So yeah, that's the first question answered. For question 2, it's asking us to draw a number line for numbers that are more than -3. So the more indicates that we're going to go on the right hand side. And over here it says including -3. So it's going to be a circle that's shaded in. So we can draw the number line and the number -3. Then we use the circle that's shaded in to indicate that -3 is included, and an arrow pointing in the general right direction to show that we're looking at numbers that are more than -3. And that's our solution.